Okay, so hi everybody. Thank you for joining me. I know there are a lot of talks happening at the same time, and they all look really interesting, so I wanted to thank you, first of all. Okay, so goedemiddag, Antwerpen. I hope that was not too terrible. I think it was pretty terrible, but I tried. I'm sorry. So my name is Ramón, and for the next 40 minutes, more or less, I'm going to talk to you about why you might not need classes in JavaScript. So before we get into that, I want to know how many of you use JavaScript on a daily basis. Quick raise of hands. Okay, so half of you, maybe a little bit more. That's fine, because we'll be covering the basics. So even if you don't use JavaScript like day to day, you'll be able to follow. So before we get into the topic, who am I? I'm a front-end web developer from Madrid, Spain. I work at a startup called Undefined Labs, in which we build developer tools to help teams ship code faster. And we're currently working on a tool called Scope that is focused on testing visibility and is especially useful in microservices architectures, which I'm hearing a lot about in this conference. So if you want to check that out and request early access, you can go to scope.dev for more info. I've been working with JavaScript and React for the past 4 years, and I really like them. But above all, what I really love is the web in general. I love its promise of an open medium accessible tool, and I really like the development community around it as well. And that's partly why I like to go to conferences and give talks. I also volunteer at LLab, which is a coding bootcamp for women in Madrid. So you probably can already tell that I care quite a bit about community and inclusion in our industry. So since I have a lot of time, let me take it just 30 seconds to say that one of the things I would really like to see as part of those community efforts is conferences stepping up their game when it comes to these issues. So things like having an actually enforceable code of conduct so that everybody can feel safe, or making an active effort to feature more diverse speaker lineups. Some conferences are already doing this, and that's great, but I would really like it to become the norm rather than the exception. So let's see if we can do better over time. If you want to reach out to me later, that's my Twitter account. My DMs are open, so you don't even need to follow me, and I'll be around for the rest of the day. If you want to come up to me and talk about my talk or whatever, I'll be glad to talk to you. So with all that being said, let's get to it. What are we going to discuss today? First, we're going to see why we got classes introduced into the language, to give you a little bit of context and history. Then we'll take a look at some common issues and pitfalls that you might bump into when working with classes in JavaScript. Then we'll go on to check some alternative patterns to using classes, and that's probably the part most of you are interested in. And finally, we're going to review a couple of recent cases of popular JavaScript frameworks moving away from classes, so that you get to see that I'm not the only crazy one talking about this. Like, there's community moving around it. Okay, so first of all, why did we get classes in the first place? Classes were introduced into the language over 4 years ago now. They were part of the 6th edition of the language spec, known as ECMAScript 2015. And when you think about classes, you tend to think of object-oriented programming, right? But it turns out that, as you might know, JavaScript already had a mechanism for object orientation. And it's something that's been there right from the very beginning of the language, the prototype. So if we already had prototypes, then why did we get classes again? Let's look at an example. Here's a simple counter written using prototypes on the left and classes on the right. We're going to be using this same example all over the talk, so take a look at it, but it's a simple one. It's just a counter that gets an initial value in the constructor, and then it has 2 methods to increment the counter and to reset it to the initial value. And so if we compare these 2 examples, you can see that, yeah, okay, like the class looks a little bit cleaner, but it's not such a dramatic difference, right? However, when you try to do inheritance with prototypes, things get much uglier and messy. Here's a StepCounter that inherits from the counter that we saw before. It's basically the same thing, but now we get the step of the counter as a parameter. So we are overriding the increment method. And as you can see, we have to do some pretty weird stuff with prototypes on the left, whereas with classes on the right, we just use the extends keyword and call super on the constructor, which is much nicer. You know, it's like regular classes in other languages. That doesn't look really, really weird. So based on what we just saw, we could say that we got classes in JavaScript as an improvement over prototypes, at least in terms of syntax. But there's probably a more important reason, and it's that classes are familiar for people new to JavaScript coming from other languages. And I don't know if you've heard, but JavaScript has become quite popular. So introducing something like classes that are a very common concept in other languages seemed like a good idea. And these two reasons have a lot to do with why we got them in JavaScript. So, OK, classes don't seem so bad, right? Like, there are legitimate practical reasons to have them in the language. We've just seen them. They're better than prototypes in terms of syntax. So what's the problem then? Well, there are actually a few ones, so let's go over them. The first and most important one to me is that classes in JavaScript create false expectations. We just said that a reason to add classes into JavaScript was because they are a familiar concept. But the thing is that classes in JavaScript are not like in other languages at all. So we are using the class word for something that doesn't really behave as you would expect from a class, and that can be problematic. Let's see how this works. Going back to our counter example from before, I haven't changed anything. This is the same thing. Let's say that now we create an instance of our counter with 0 as an initial value. And then we call the increment method, and we check the counter value, and it's now 1. So, OK, that works. It went from 0 to 1. But what happens if I now do this? Because as you might know, classes in JavaScript are basically syntactic sugar over prototypes. So first notice that I can actually do this. I can actually access the underlying prototype. So I would call that a pre-leak abstraction. But besides that, because you might be thinking, OK, but I'm not going to do this like on purpose. Like I can just work with classes. OK, that's valid. But besides this, the thing is that the prototype is a living object that is referenced from other instances. So if I change the prototype like this, even though the counter instance was created before, it is affected anyway. So if I now call increment, I get 0 instead of 2, because I modify the increment method in the prototype to subtract instead of to add a unit. So yeah, this doesn't quite match the expectations most of us have about classes as sort of static blueprints. And that's the difference. Typically, a class defines a type, which is later instantiated at runtime. Whereas a prototype in JavaScript is a living object instance itself, then referenced by other objects. And living is the key word here. Unlike classes, definitions in prototypes are not statically copied at declaration time. Prototypes are living objects. They are instances themselves. So you can modify them, and the changes will affect previously instantiated objects. And again, since classes in JavaScript are syntactic sugar over prototypes, they behave this way as well. You are not getting away from this. Another problem with classes in JavaScript is that, for example, here you can notice that I can access the value field of the counter from the outside. And you would think that if we are writing a counter class with getters and setters, as we did, you don't want to expose the the value itself. We want to have that as a private member, where it turns out that we don't have private members in JavaScript classes. They lack many features that you have in other languages and that you would expect from a class. We don't have private members, we don't have static members, we don't have other things like decorators, for example. And there are proposals for all these things, but they're not part of the standard yet. And they will likely take some time to land, as they're tricky to implement on top of prototypes. And sure, if you use TypeScript, you get some of these things. You get public, protected, and private fields and methods. You get read-only properties. You even get abstract classes. But that's in TypeScript, not in the JavaScript standard. So maybe we'll get there eventually, but we are not there yet. And honestly, I'm not even sure we want or need some of these things personally. Like, for example, static methods. They make sense in languages like Java, where everything needs to be a class. But in JavaScript, you can define a standalone function and use it from wherever you need, including from inside a class. I'm not saying there are no valid cases for static methods in JavaScript classes. There are, but less than we would think. Like, a lot of things can be solved just with a function that you use from when you want, from wherever you want. But okay, besides this problem, besides this expectations not much problem, there's something else that is very practical and that happens all the time, and it's context binding. Handling the this keyword in JavaScript classes is confusing and very error prone. If you've worked with them, I'm sure you know about this. And these kind of problems with context show up with asynchronous code, which is basically everyday code in the browser. So you bump into this all the time if you are developing a web application. Let's say that now we have a button class that just gets a click handler. And we instantiate our counter from before and use it. I use the increment method of the counter as the click handler for the button. So the idea here, of course, is that whenever you click on the button, the counter is incremented. Simple. Okay, if we do this and now look at the button, at the counter, it turns out that the counter is not actually incrementing. And if we look at the button instance, we see that it has a value property in it that is not a number. Some of you might already know what's happening. And the problem is that the increment method of the counter uses the this keyword internally to increment the counter. It does this.value ++ to add 1 to the counter. And we're passing it as the click handler to the button in this line that we're seeing here highlighted. The problem is that the this keyword in this line is actually the button, not the counter. So button.value is undefined, undefined +1, not a number. This happens all the time with classes. So the solution is to bind the increment method to the counter instance so that everything works. And we can do that on every call, which is, error prone because we have to do it every time. We might forget. We can do it with the actual binding with the bind method or use an arrow function. So yeah, this is error prone because we're doing it in every call. So okay, we can move it to the constructor of the class. It is safer, but the syntax is not very nice. But that's no problem. We have a class field arrow function proposal, so we can write it this way. The syntax is nicer, so okay, we could be fine with this. But now the problem is that no matter which way you do the binding, if we look at the prototype of the counter, we get the constructor and the reset method, but we don't get the increment method. And this is because the increment method is no longer a class method, it's an instance property. If we go back to here, what we're doing is on the constructor, when the instance is instantiated, we are declaring a property on the instance, and we are binding the method. So yeah, it's no longer a class method. It's an instance property. It's added to every new instance in the constructor in runtime. So again, classes are supposed to be a blueprint, and instances are supposed to reference the class methods, but here we are creating a new function for every instance. So again, expectations, not quite much. There are also some performance implications, but I'd say that's minor compared to other problems, like the ones we've seen. And on top of all this, classes are harder to deal with for tools. They don't minify very well, which results in larger bundle sizes. For example, automatic dev code removal of class methods is not easy. Removing unused functions is much easier. And also method names cannot be safely minified. Most minifiers leave them as they are, whereas with functions you get the function names minified. Classes are also not very friendly to some advanced techniques either, like ahead of time compilation. They make it harder, and they also make hot reloading unreliable. So let's say that we might want to avoid classes, at least in some instances, because of the problems we've seen. But surely we don't want to go back to prototypes, right? And after all, classes are just prototypes under the hood. So then what's left? Well, what's left are just functions. We can take advantage of core fundamental features of JavaScript, like closures, to do similar things to what we do with classes, but only with functions. And in a different way, but it's pretty much the same in practical terms. We can emulate object-oriented programming features typically implemented with classes like inheritance, encapsulation, or polymorphism. And we are going to see how in a second. And we can also implement common design patterns like factories or singletons. Again, we're going to see examples of that. So let's take a look at how we can leverage closures to do these things. First of all, closures help with encapsulation. Here we have a CreateCounter factory function. A factory function is just a function that returns an instance, in this case in the form of an object. So this would be the equivalent of our counter class from before. And first notice that we don't need to save the initial value in the instance. Like we don't need to put it anywhere, because due to the way closures work, we are getting the init value as a parameter, and we can reference it from the reset property that we are returning in the object, and everything works. And also notice how the counter value is actually private. Again, we are declaring a variable here that is private to the function. And we can access it because the way closures work, it's binded in this object we are returning. So we get from the getValue property, we can actually access the value, but from outside we cannot access to value directly. So that's another benefit. And sure, we are creating new objects all the time now. There are no references, but and that could be a problem in some cases if you have like really serious performance concerns, which is like you really need to be doing something crazy for this to be a problem. But in any case, that was already happening with classes when we had to bind some methods. So it's not such a dramatic difference. And in return, we get private members, as we've seen, and we also avoid issues with the this keyword because we are not using the this keyword, so there are no issues to be had. In fact, if we do something similar to what we did before with the button class, we now have a createButton function that is sort of the same thing. Closures give us this implicit binding. So now we don't have to worry. We can do createButton and pass the increment method from the counter, and everything works out as expected. No weird stuff. No need to bind anything. And you might think that this is a very simple example, but it's something actually relevant and useful in real life. I'm sure you've all done this at some point. A movie API class that gets a token in the constructor, and then that token can be used from all the methods. So the idea is that you don't have like a bunch of classes and you need to be passing the token all the time. You just instantiate your API class, and then the token is there, and you just call the methods. You will do it like that, new movie API, you pass a token, and then you call the methods, and that works. Well, we can do the same thing, similar example to what we saw before. We can have a create movie API factory function. It gets the token as a parameter, and again, we don't need to save it anywhere. We just can reference it from the add_favorite property, thanks to the power of closures. And the way we use it is pretty much the same. Instead of new movie API, we just call create movie API, but other than that, it's exactly the same. Object composition is another powerful concept that we can use. It can help us implement equivalent patterns to inheritance and polymorphism, again with a different thinking model, but sort of more or less the same. So we now have a CreateBaseCounter function that is almost like CreateCounter, the CreateCounter we saw before, but instead of the increment method, it has a setValue method. So think about this as sort of a base class that we're going to use to build the actual counters that we're going to use in our production code, so to speak. So if we wanted to do the StepCounter from before, there you go. We call CreateBaseCounter with the initial value, and notice that we get setValue and then the rest of the properties. And this is because we want to use setValue inside of our StepCounter implementation, but we don't want to expose it. We want to expose an increment method like before. So as you can see, what we return is an object that has all the base counter properties, which are basically the reset and the get value. And then we define a new increment method, and we use setValue. But we are just using it here. We are not exposing it. We are using it privately. So again, we've done something similar to what we were doing before. And if we wanted to do the create counter based on this base counter, same idea, we can do it like this. Now we do get value +1, and we could even, same idea. And we could even just use the step counter, but passing the 1 as a step, as the step value. So we can basically have objects that mix and match. And notice that if we wanted to override properties, we can do that as well. In that object, let's say that CreateBaseCounter already had a inc property. Since we are then in our object defining another inc property later, the way JavaScript works, it will get overridden. So we can add properties, and we get that as well. Function composition and higher order functions, and some other resources that we have in our functions toolbox. And we can use them to implement some patterns. For example, something similar to decorators or mixins. This is a function called withLogin that gets a method, and this is a higher order function, which is, if you've never heard of the term, it's just a function that returns another function. That's it. So we get the method, and we return another function that console logs the argument. That's why it's called withLogin, and then calls the original method with the same arguments. And now if we want to decorate some function we have, we just do withLogin, we pass our function, and we have the decorated function. A little bit more verbose than doing the add thing with a decorator in a class, but it achieves the same thing. And finally, in modern JavaScript, we also have modules. They provide encapsulation, again, like closures, and can also help implement some design patterns. for example, a singleton. This is our counter from before, but it is a singleton now. So the only thing the module is exporting is create singleton counter function. And then all this function does is we have an instance variable in the module that is not exposed, it's private to the module. So then when we call create singleton counter, we check if we already have an instance. If we don't, we create the instance and assign it to the instance variable. And if we already had it, we just return it. And we have a singleton in 11 lines. You can, there are ways to do singletons with classes in JavaScript. You can look it up. It's, if you want to be safe about it, it's a little bit messy. This is, in comparison, this is simpler. And again, it achieves basically the same purpose. So, OK. We've just seen some examples of, we've seen the problems with classes. We've seen some examples, some things that we can do to avoid them. So is this just something I'm saying? Am I a crazy person that just has some trauma with classes or something and doesn't want to use them? Or is there actually something happening in the community? Well, as I said at the beginning, there are examples of popular JavaScript frameworks that are moving away from classes. We are going to check a couple of them. So first we have React. React already had classes. They had an API to define components based on JavaScript classes. One of the issues with that, or the things that were not so nice, is that they also had a function API. So whenever you wrote a function and wanted to add state, for example, you needed to rewrite that function into a class to add state. So that was a little bit cumbersome. So they came up last year with something called React hooks, which are basically functions that the framework is providing to encapsulate state, but still using you are using you're writing your components as a function. You don't need to use classes. So this would be an example of it. I'm not going to get much into the syntax details because it really doesn't matter. But basically, you have your component defined as a class, and we use this useState function that React provides. You pass it the initial value, and then you get a value, in this case the counter, and a function to update the value, sort of a setCounter in this example. This is the counter example, by the way. If you haven't realized by now, it's always the counter. So you can use the counter value in your render as it is, and then you can use the setCounter the same way. And notice how, since this is a function, everything is in the same closure. It's not like a class in which you have different methods, and then, for example, this inc function, you need to do the binding, because otherwise it's not going to work. You don't need to do any of that. It's everything in the same closure, so it's taking advantage of the way closures work, so that you have everything available to you, and you don't need to do any weird things as you would need to with classes. And then another example of this transition away from classes is Beyou. And this is actually an interesting example because Beyou didn't have classes to begin with. There was a proposal at some point last year to introduce a class-based API to define components in Beyou. And it was actually dropped eventually in favor of what they call the Beyou Composition API, which is inspired by React hooks. It's actually a pretty similar idea if you look at the code. They have a setup property in this case, and inside it you just call your hooks. They're not called hooks, but it's the same idea. In this case, we are defining a state by calling the reactive function. This tells Beyou that it needs to keep track of this state. and you just use it on your template. And same thing for the setter. You just define the function and use it on the template. So it's a very similar idea, and again, the interesting thing in the case of Beyou is that they thought about adding classes to the framework, and then started bumping into these problems. Like, for example, they wanted to use decorators for certain things, but the problem is that decorators are still is still a proposal in ECMAScript. So, and at the same time, they wanted to improve how static type checkers worked with Beyou. So they said, okay, TypeScript has decorators, but the thing is that the way TypeScript implements decorators is very different from the way that it's been discussed for the actual JavaScript language spec. So in the end, they found some issues. Also with the binding of the methods, their proposal actually explicitly said that they were going to do automatic binding. So basically, they didn't want people to have to remember to bind their methods whenever appropriate. So they were going to bind every method you had in the class, basically, which is a way to solve the problem. But I'd say it sounds like a workaround to me. I mean, if you have to do that, it's because there's an inherent problem with it. So what did these frameworks realize, and why did they move away from classes, besides all the problems that we've seen? Well, one interesting thing is that they realized that classes, the way we were using classes to define components in UI frameworks, mixes concerns. For example, you could have a component that needs to do a network request and also needs to add an event handler for when the user moves the mouse around. So what happened is that you need to do the network request and you need to add the event listener when the component mounts, and then you need to remove the event listener when the component unmounts. So all frameworks basically did the same thing. They would provide you with what they call lifecycle methods. That's the way they are calling React, but they're equivalents in other frameworks. So you would have to basically split out your business logic into all these methods. So you would have the network requesting component did mount or equivalent methods, and you'd have the add event listener in component did mount as well. And then in component will unmount, you would have the removal of the listener. So basically, instead of grouping your code by features, you were grouping it by the moment that they happen to the moment that they happen to run in the component lifecycle, which is not really good for maintainability. You could really end up with some big components. And with this approach based in functions, if we go back to the Beyou example, notice how everything that is inside setup is regular JavaScript. There's nothing strange there. So you could actually take all that code and extract it to a function and call it useCounter, for example, and then just call it from the setup. And again, if you had a function to add an event listener or remove an event listener, you could write it as another function, because you did, in the same way you get this Beyou reactive thing, you'll get similar things to hook onto the lifecycle methods of the component. So you now can encapsulate your logic, your business logic, in functions, regardless of the moment in time in which they will run. And you can even reuse these functions across components, and in your setup you will just have the calls to them. And that's related to the point before. They also realized that classes tend to lead to more convoluted patterns. If you've worked with React, I'm sure you know of higher-order components, or even mixins from before, or mixes in general in classes. because we had all this thing of needing to define things all scattered all around your component, if you wanted to encapsulate in that example the event handler for the mouse, if you wanted to encapsulate that in a component, okay, you can write a component, put some things in component in mount, put some things in component without mount, but components need a render method. So how are you going to reuse that in other component? Well, you get into patterns like higher order components or render props that are really hard to wrap your head around. I mean, when they click, is great, and you can do all sorts of things, and they're really nice. But these function-based APIs are much simpler for that. As we've seen, you can just create functions and reuse it across your components. And with things like mixins, for example, there are additional concerns. They're more difficult to follow because if you have something that is injecting props into your component, the sources are really unclear. Like you see a prop, but you don't know which mixin exactly is coming from, and they could even clash. You can have namespace clashing. So there are additional issues with that. And finally, what they found when doing this, especially in the case of Beyou, which is more recent, is that this way of working, so to speak, is more friendly to static type checkers. Since it's all mostly plain variables and function, it's easier to type manually. But not only that, but time inference works much better than in classes that end up forcing you to do these patterns that we talked about, like the higher order component thing. Because in those patterns, you usually have the props that are the props from your component, and then you have to mix that with props coming from the higher order component. And in the end, that's difficult to express with types, whereas in this case with variables and functions, it's much easier. Since it leads to simpler patterns, they are easier to type. And again, type inference works better. So these are the main things they found out, plus all the benefits previously mentioned, like bundle sizes. That's something that they really stressed out. The folks from Beyou, they really mentioned that in their RFC for the Beyou composition API, that this will help them make your bundles smaller because of the things we saw before. Okay, so that was quite a lot. So before we finish, let's do a quick recap of the main points of the talk so you can remember at least something from all this. So first, the most important thing for me, if you have to remember just one thing from this talk, is that you need to adjust your expectations when working with classes in JavaScript. It might look like I'm saying that you shouldn't use classes. I'm not saying that. There are valid use cases. I'm not saying you shouldn't use classes. I'm saying you should be really aware that they do not work as in other languages, especially if you are coming from other languages like Java, for example. They're really different. And maybe you want to learn at least a little bit about the prototypes behind them, because as we've seen, they are there. Like even if you don't see them, even if you don't see the prototype word, they are there. You're going to bump into its quirks. Related to that, watch out for issues with context and the this keyword. Remember to bind your methods with dealing with asynchronous code, or use a framework that binds the hell out of everything for you. And also look for the encapsulation issues we mentioned. And finally, unless there are performance concerns because you have tons of instances, or unless classes are imposed by your framework, which as we've seen, it's less common nowadays, consider using functions, at least some of the time. Things like closures, modules, object composition, function composition, they are all very powerful and they feel very natural to the language. If you've been working with JavaScript for a while, you can see that they're simple to get. They're just JavaScript. And in fact, things like closures are so fundamental to the language that you're going to have to learn them anyway if you want to be efficient with JavaScript. So you might as well take full advantage of them and try to use it for other things, as we've seen today. So that's really all I have. Thank you for your attention. Again, if you have any questions, you can come up to me later or send me a DM in Twitter, and I'll be happy to talk to you. So thank you.